Hello, everybody. This is Mark Sage, Executive Director of the AI for Enterprise Alliance, the area, and with our latest fireside chat with one of our newest members, but a company that's doing some amazing stuff, and we've already included them in one of our kind of current research projects as well. So, Shazaan, welcome. MultiSet AI. Please just introduce yourself and talk a little bit about the company, and then I'll ask you some hopefully teasing and difficult questions.
Thank you, Mark. Thank you for having me. Hi, everyone. My name is Shazaan Khan. I am a co-founder and the CEO of MultiSet AI. We build enterprise-grade visual positioning systems for augmented reality overlays for robotics, smart glasses, and all the new fleet of enterprise devices entering the real world today. I'm excited to be here.
Awesome. Well, let's just jump into the questions straight away. And I'm certainly seeing a lot of enterprises now have a whole bunch of spatial data scattered across kind of at least half a dozen capture formats. We've got Matterport for facilities, LiDAR for CAD and BIM teams, Gaussian splats for drone surveys, point clouds, inspection vendor. There's a lot going on at the moment. From where you sit within MultiSet AI, what's the cost of that fragmentation? And what should ERA members and the wider ecosystem be asking their VPS and AR vendors to commit to so they don't end up with kind of locked into proprietary capture pipelines?
Great question. So I'll start with the thing that I suspect this audience already feels, but maybe sometimes doesn't say out loud. The lock-in fight of the next decade isn't headsets. It is that spatial data. And here's what I mean by that. If I'm to call, every one of you has the same mess. Matterport from facilities, LiDAR from the BIM team, splats from a drone survey, point clouds from an inspection vendor, 4 formats, 4 owners, 4 reasons they were captured, and rightly so. People use the best instrument for the end outcome and goal that they're going for. But that fragmentation is annoying, but it isn't the trap. The trap is really what you do about it. You get tired of that mess, you bring in a VPS or an AR platform to clean it up, and it only ingests its own capture pipeline. So you use the system. You rescan the whole facility with their tool, and now your spatial data isn't yours anymore. It's a function of one vendor's roadmap and one vendor's pricing. The day you want to move out, you start over from an empty map. You've all lived a version of this with some system in your stack. What makes spatial worse is that the data is expensive to capture and it goes stale the moment the floor layout changes. So you're not rescanning it once, you're rescanning forever. And this is the whole reason we built our platform to be scan agnostic. Take in whatever you already have, whatever captured it, and don't make the enterprise reshoot the world just to change vendors. It's also why we built into the systems your crews already live in. Like, for example, Esri's field maps. Instead of demanding they come to us, the map should meet the work where it happens. So the question I'd put to every vendor is really narrow. Will you work with the capture tools I already own? And will you hand me my maps in a format I can take somewhere else? There's real movement on open formats right now. The splat work at Chronos, GeoPose at the OGC. Push on it, hold them to it. Treat the maps as an asset you own and not a service you rent.
Absolutely awesome, because those organizations have been going on for a while, haven't they? But now, you're absolutely right, it's really in focus of kind of enterprises, and be able to manage their data is critical. So it's a great answer, so thank you very much for that. Let's go into a kind of another theme now. So digital twins are everywhere. We also have a sister organization called the Digital Twin Consortium within the area, and it's in industrial roadmaps everywhere. I hear about it all the time, but most of them seem to be stalling in that kind of diagnostic or predictive sort of phase. And they're not reaching actually the technicians on the shop floor or the robots doing the inspection, where actually it's the most use. So where does kind of VPS sit in closing that loop, and how do you see localization shifting from kind of an AR feature to a shared infrastructure between connected workers, autonomous robots, and AI agents, which I think is a big question on everyone's mind at the moment?
Yeah, great question. Let me tell you about a maintenance technician at one of our customers. It's a Fortune 100 industrial operator. Picture the scene. There's a critical incident on the line, and he's standing in the plant, maybe a few meters, maybe a few hundred meters from the asset that's failing, looking at a tablet, and it's showing the digital twin, the reality capture. It's a beautiful live model, sensor data streaming in, the fault flagged in red on his iPad. The twin knows exactly what's wrong. What it cannot tell him, though, is which of the, let's say, 40 near identical units in front of him is the one in red. He only sees it on a screen. So what does he do? He does what technicians have always done. He walks the rows, reads asset tags off a clipboard, tagged on the asset as well on paper, and matches them by hand. That gap between what a twin knows and a person standing right there who can't act on it is the thing nobody puts on the roadmap. And it's exactly where most twin programs quietly stall. There was an editorial, I think, earlier this year, in the Journal of Quality and Maintenance Engineering that said it cleanly. The predictive problem is largely solved. The algorithms can already tell you a bearing is degrading or a heat exchanger is fouling. What is not solved is the prescriptive problem. Turning that prediction into a specific action, a technician can then execute and an auditor can trace back. The data is there, like but the doing is missing. And let's just go into the doing. The reason the doing is missing is a coordinate problem. The twin lives in its own coordinate space, in its own wall garden, captured by another vendor. The technician and the robot live in the physical building. Nothing connects the two. There's a divide. The model and the person are standing in the same place, and they don't share a frame of reference. To put it cleanly. And that is the whole job of visual positioning system. It gives any device, a phone, a pair of glasses, a robot, any camera bearing agent, its exact position. And not only that, it's also its orientation inside the real space. It's essentially what's in the field of vision, not just a radius of where you're in, right? Inside the real space, and it's aligned to the twin's coordinates. It's centimeter level, 6 degrees of freedom, and the accuracy bar here is unforgiving, which I know this room will appreciate, because I think on Area's own 15th research project, it measured exactly this accuracy across the VPS field. An annotation that drifts half a meter off the valve is worse than no annotation at all. Get the positioning right, and the red fault on the screen finally has a physical location. And the work order stopped saying, unit 41. It actually points at the unit in front of the person in the building. But I want to come back to the technician, Mark, because that's who we built for.
Absolutely,
so, once that localization layer was in, the prediction landed where he was standing. No more walking the rows. He was finding maintenance assets about two and a half times faster. And on critical incidents like that one, mean time to repair, MTTR, which is a greatly tracked KPI in manufacturing facilities, it dropped by roughly 4 times. Same twin, same sensors, the same data that was already sitting there. And this isn't a one-site pilot. Our platform is localizing devices across facilities in over 100 countries today. The only thing that changed for that technician was closing the last few feet between the model is in his hands. But let me go, just the parting thing to this question is that it goes well past people. The same layer that pins the work order to the valve is exactly what an inspection robot uses to navigate and what a spatial AI agent will need just to reason about the building at all. What's one coordinate frame shared across the connected worker, shared across the mobile robot, as well as the agent. That's the shift I'd leave you with. The twin gave us the model. This layer is what finally lets the model act on the floor across every device walking through it.
Amazing. Again, thank you for those insights. What I really love, and as you'll get to know me even more, this is my big thing, is around the ROI. People buy benefits, they buy value, and you're clearly showing that there's some, not only on the critical activities, which is really important, but the time savings there is huge, and that can turn into a big dollar, euro, whatever saving it is. So it's great that we can talk about the kind of ROI piece there. Going to change tact a little bit and talk about wearable AR devices. And, we're getting to that stage now of price and form factor, sub $3,000 type glasses, on-device AI. Multiple Android XR platforms are coming out and announcements on that, which is great. And as you probably know, the latest area research project is kind of building a taxonomy and a kind of a tool to look at these different AI-enabled glasses to match against different use cases and kind of help enterprises look at the different problems and get the right kind of devices. But from a kind of a localization and spatial data standpoint, what should enterprises be doing in the next 12 months to be ready when their workforce shows up wearing these kind of glasses? And what's the one mistake you see at the moment that's being kind of repeated?
Mm-hmm. Mark, I love your questions. Very insightful and straight to the point. I entered this industry from the wrong side of the field or the wrong side of the street. Like I wore a Microsoft HoloLens unit back in 2016 at a Alberta oil and sands client. And it changed my life. I think I saw the future in front of me. So it's like there's parallels to it today. But I'll be blunt about, where we are today. This, we're at a stage where this is Android after the iPhone. iPhone launched the first, device and a marketplace, and now Android's phone. Like we're at that sort of stage. And a lot of enterprises are, about to make the same Google Glass mistake a second time. Here's the part that's already settled. This is not a forecast. I'll give you some metrics. So last year, smart glasses became roughly half of all XR shipped, up from about a quarter the year before. In the first half of the year alone, shipments more than doubled this year. Sub $300 AI glasses, like you mentioned, like I won't take names, but the processing is moving on device, and Google's Android XR putting multiple hardware partners in this market is clearly an inflection point. Like my point is the form factor question is closed. People will wear these, right? Which means the real event for our audience isn't really a new hardware launch. It's that your workforce is going to show up wearing these whether or not IT provisioned them. The same way you ended up supporting personal phones and devices in bring your own devices, right? And think about what they will do with them, right, in an enterprise environment, because it's exactly the use cases I think area has been chasing for a decade. Finally, hands-free. A field tech following work instructions without holding a tablet, an inspector logging a finding just by looking at it, a junior operator getting a remote expert's guidance pinned into their actual field of view with where both hands sort of stay on the equipment. The glasses are the form factor those use cases have always been waiting for, because that was the entire point was to free our hands. And here's the catch, and it's the same catch as everything else I've said. A pair of glasses is just a screen on your face until it knows precisely where you're standing and can pin information to the real world in front of you. That's a localization problem. It's a spatial map problem. It has nothing to do with the frames you buy. So my one piece of advice for the next 12 months, let's say, or even shorter, even in the next 6 months, is to stop treating this as a hardware decision, because that is the Google Glass mistake.
Yeah.
The first time around, everyone fixated on the device. The device was never the hard part. The teams that got burned are the ones, let's say, who picked a headset, built all their content tuned to it, then can't move to next year's model without rebuilding everything, because the spatial work was captured inside that vendor's closed ecosystem and pipeline. You're committing, let's say, to a 3-year device choice in a market that's turning over every 12 months. And the price for getting it right is bigger than glasses, Mark. If your spatial layer is device independent, the same map that guides the worker's glasses also positions the phone in another worker's hand and the robot moving down the same aisle. One map, every device, one coordinate frame. And that's the connected worker and robotics picture everyone keeps putting on slides. It only holds together if the map underneath is shared. So I'll end off, by saying, it brings me back to where we started. The headset is the part that changes. The map of your building is the part that should outlive every device that reads it. Build the spatial layer device independent and scan agnostic, and the glasses become the easy swappable part.
You know what? I'm not sure I can add much to that because I think that's a great way to finish this this amazing talk. Shazaan, thank you very much indeed. It's been great. We're looking forward to carry on working with you. Remember, the company is MultiSet AI. Can you just do the website just to remind people?
It's www.multiset.ai.
AI, perfect. Okay. And thank you very much for those insights and looking forward to working with you.